What's up, class? This is our third online lecture. We're going to go over linear system equations. Last week, we kind of looked at this a little bit, but this upcoming week, we will look about this more in depth. And for this video, this will be extra practice for your review assessment practice and for your actual assessment. So let's take a look. Linear system equations just simply means that there exists some solution. So some solution that satisfies both equations. We could say both, or we could say all, because technically you could have more than two, but for the sake of this course, I believe we will only look at two. So let's actually look at an example to figure out what this means in context. So let's say, for example, I have two different equations, right? On the x-axis, let's say I'm just plotting units. On the y-axis, let's say I'm plotting price. Right, and then let's say I have two different linear equations, supply and demand. Right, so this is a free market exchange plot, right, standard in economics. What this essentially is telling me is, let's say that this graph is representing some clothing store. We could say that it may be Under Armour or Asics or Nike or whatever the case may be. If I am at this point on the graph, right, so if I have a high demand but I have a low supply, right, or if I have a high supply but a low demand, in both cases I'm losing money. So how am I losing money if I have a high demand but low supply? What that essentially means is, imagine if you were going to a store and let's say it's the grand opening and you get in line and let's say there's like 50 customers in line. Let's say you're all the way in the back, so you're like the 49th, 50th person in the line. By the time you get inside the store, if the clerk informs you, hey, we don't have any more of the products that you're looking for, that store lost money. It lost money because you were planning to buy something. You were planning to buy a product. And because they didn't have it in stock, they couldn't make that money from you. Right? So that's money lost on their end. If they have high supply and low demand, they are also losing money because let's say that you are going to a clothing store where they haven't had a customer in 2 weeks and they have an overload of stock because nobody is buying anything. Well, all of that overload in stock is a loss of money because eventually they'll have to redo their stock and start shelving up newer products so that they stay relevant, things of that nature, right? So at this point in the graph, this is our point of optimum. This, in the context of our linear solutions, is our solution. Right? Because what that point in the graph is telling me is that there exists some solution, some coordinate point where both the supply curve and the demand curve are optimized. So there exists a solution where I will have enough supply and enough demand so that I don't have excess product or I don't have scarce demand. That makes sense? So let's take a look at a few problems to figure out what this means. Let's say I have 2x plus 3y equals 21 and x plus y equals 3. How to solve this, what I would like to do is just stack them. So we have 2x plus 3y equals 21, if x plus y equals 3, all right, and then we could just stack these and add them. All right, so 2x plus x is 3x, 3y plus y is 4y, 21 plus 3 is 24. Let's solve for one of these variables. I'd say let's solve for x. So over here we can subtract our 4y, subtract our 4y. We're left with 3x equals 24 minus 4y. From here I can divide the 3. That cancels, so now we have x equals to 24 divided by 3 is 8 minus 4 over 3y. So now that we have our x, what I can do with that x is I can take it and plug it in for either one of these x's. Either one. I would rather use this one because this looks like an easier equation. So let's do that. So now we have 8 minus 4 over 3y. Going in for our x. plus y equals 3. So now what I can do is, this is a positive 8. So to get rid of that, we subtract 8. That cancels. Do it to this side of the equal sign. Now you have negative 4 over 3y plus y equals negative 5. Now what I can do is negative 4 over 3 plus 1. If I wanted to get this y with a denominator of 3, what divided by 3 would give me 1? Well, that's 3. So now we have negative 4 over 3y plus 3 over 3y. And negative 4 plus 3 is negative 1. So now we have negative 1/3 y. So we have negative 1/3 y equals negative 5. Divide my 1/3. Divide my 1/3. And then from here, I have negative 5 divided by negative 1 over 3. Remember our rule of thumb, we had keep it, change it, flip it, right? In this context, what I would do is keep negative 5 over 1, change division to multiplication, and flip negative 1 over 3, which would then become negative 3 over 1. Negative 5 times negative 3 is positive 15. So this is in fact my y. So now that I have my y, let's plug our y in for x, or plug our y in for y. My apologies. So we plug our y in for the y. Let's continue to use this equation because this one just again looks easier. So you have x plus 15 equal to 3. Let's subtract our 15 from this side, subtract our 15 from this side. We have x equals negative 12. So what this is telling me is that the coordinate point negative 12, 15, that is the solution for this problem. Now let's figure out if that is actually the case. Let's plug negative 12 in for x and 15 in for y and see what we get. So again, let's use both of these equations. So x plus y equals 3. So negative 12 plus 15 equals 3. Does that work? Yes. Negative 12 plus 15 is 3. 3 equals 3. That is a solution. Now let's take a look at our other problem, other linear equation. We have 2x plus 3y equals 21. So 2x is 2 times negative 12 plus 3y plus 3 times 15 equals 21. Yep, so negative 12 times 2 is negative 24 plus 3 times 15 is 45 and equals 21. So negative 24 plus 45 should give me 21. Let's confirm this real quick. Yes, 21 equals 21. Yep, checks out. So this is a optimal solution, right? So if we were to graph this, it would look something like cross right here, right, where we have our solution. Let's take a look at another problem. We have x minus 2y equals negative 7, and we have x minus y equals negative 4. Again, let's add these together. X plus x is 2x, negative 2y minus y is negative 3y, negative 7 minus 4 is negative 11. Let's solve for x. Right here we would add our 3y, add our 3y. These would cancel. 2x is equal to negative 11 plus 3y. Divide our 2. Right, these would cancel, so now it's x equal to negative 11 plus 3y over 2. Now that we have our x, let's plug our x back in for our x. I like this equation again because that just looks easier. So we in fact have our x minus y equals negative 4. Our x is negative 11 plus 3y over 2 minus y equals negative 4. From here, what I would like to do is actually put that negative y over 2. So what divided by negative 1? Let's see. We were looking for negative 2 at the bottom, so we would have 2 over 2, right? Because 2 divided by 2, in fact, does give me negative 1. So from here, what I could do is negative 11 plus 3y over 2 minus 2 over 2y. All right, we'll figure that out. Well, this also looks like this. So from here, what I could do is, what's 3y minus 2y? 1y, right? Positive 1y. So this would equal negative 11, right? Plus y over 2 equals negative 4. From here, I can multiply my 2, because that's the opposite of division. That cancels. This becomes negative 11 plus y equals negative 8. From here, I can add my 11. Right, that cancels, so y equals 3. From here, I can plug 3 back into either one of these equations and get an answer, so let's do that. So I'm plugging that 3, that y, in for either one of these y's. That'll work. So let's use this equation because that just looks easier. So x minus y equals negative 4. So we have x, right, minus y, so minus 3 equals negative 4. So let's actually add that 3 over. Cancels. X is equal to negative 1. So what this is telling me, at negative 1, 3, then I have a solution. All right, that is what this is informing me. Well, let's actually corroborate this. Let's confirm this. Because we have x minus 2y equals negative 7. So x minus 2y equals negative 7. And we also had x minus y equals negative 4. Let's plug in our x and y to figure out if we get a solution that equals what is on our other side of the equal sign. So negative 1, plug that in for x, minus 2, our y was 3. So that give me negative 7. We have negative 1 minus what's negative 2 times 3, negative 6, equals negative 7. Negative 1 minus 6 is negative 7, equals negative 7. Yes, that is a solution. Take a look at this one. We have negative 1 in for x minus y. So minus 3, that equals negative 4. Negative 1 minus 3 is negative 4, equal to negative 4. Yes, that is also a solution. So if we take a look back at our context in the beginning, right, our solution means that we have found the optimized point for both linear equations. If you need further assistance with this, please email me or reach out. If you would like to continue to look at other resources, you can do so. I highly encourage that. Use this video if you would like for your review assessment practice or for any point in the semester where you would need to refer back to this concept. This video will always be available to you. All right, I hope you guys have a great weekend. I look forward to seeing you guys next week.